Hey guys, my name is Dylan, and I'm going to be showing you how to package up a containerized application into an Ansible playbook bundle, which will then be deployed via the Ansible service broker onto OpenShift Origin. So before we get started, I want to talk about a little bit about what I have installed. I have an OpenShift Origin cluster with the Ansible service broker and the service catalog both running on it and pre-configured. To do this, I'm using the Fuser Cat ASB project on the dev branch. I'll include a link in the description for this, but this is essentially an entirely scripted out deployment of OpenShift with the Ansible Service Broker and Service Catalog added. So with that said, the application that we are going to package up today is a golang app, and it is the Golang client for the Ethereum blockchain. I chose this application for fun, but I also think that the big use case out of this is taking any containerized Golang app with some type of binary, like where we're running the geth command, running that binary with configurable arguments becomes really easy with an APB and allows you to deploy these types of applications to OpenShift using the full UI experience. So to do this, let's move to our terminal. And you can see in this folder, I have nothing except for this demo files folder, which I'll be utilizing later. To start off, we're going to do an APB init with our organization of DY Murray. That's me. And our name is going to be Ethereum APB. So you'll see that that created this folder Ethereum APB in here. Let's look in here. And anyone that's worked with APBs before will see a pretty familiar folder structure. We have APB YAML, which is just going to be our spec, our Docker file, and then two default playbooks, which really are just corresponding to their associated rules down here, provision and deprovision. For the sake of this demo, I'm only going to go through provision, just to show you how easy it is to get up and running. So first, let's take a look at APB YAML. This is our spec. Let's make the description something that makes sense for this app. Bindable should be set to false unless I was connecting this to some database or some other application, and all the other options look fine for now. The parameters I'm going to leave as empty for the first pass, and I want to come back and iterate with parameters after I show you how to populate this in the UI. So the only thing we're really missing is a metadata field, and this metadata field will essentially allow us to populate our APB with some information that the service catalog can use to show an icon, a display name, some descriptions, and then a documentation URL. So to do this, I've saved us some typing. I'm going to append this into our YAML file, and I want to show you what I have here. So here's our metadata field. It's got a display name, a long description, an image URL, and a documentation URL. I'm using Ethereum's asset, official asset, and then their GitHub page to link back to them. So that's really all you need for a spec with no parameters. If I write that, I now want to encode that spec onto the Docker file, because remember, this Docker file has no label associated with the spec yet. To do that, we can type in APB prepare. If we look back at the Docker file, you'll see a base64 encoded spec of that YAML file. So that looks good to me. Really, all we have left now is to actually change this task file here for provision to use the Go client's image on Docker Hub, and then some configuration options after that for the service and the route. So let's look in here to see what it comes in by default with APB init. It's a lot of commented code, but essentially points to you the three things that you need to get started: a deployment configuration, a service, and a route. And you can see in the deployment config it just specifies some type of image on Docker Hub to use. So, save us some more typing. I have done this for us. So we're back in this provision task main. And here we have the Ethereum deployment config. We're going to only deploy one pod. And the interesting part is really this container spec. So notice that image, I'm now pointing to Ethereum's organization with a client Go image. And if you recall, I showed you that back here. This is going to give you some more information on how to actually run this and plug it into your application. But since I already know how to do this, let's see. We're running that geth command, like I said, and then a few flags. I'm going to run it with the RPC server running on address 0000 as opposed to localhost. That RPC server is actually going to be exposed on port 8545. I'm going to interact with that at the end of the demo to prove that what we have is actually working. This 30303 port is meant for the Ethereum console service. I include that in the service spec, but I actually want the route to point to the RPC server. So you can see I have 2 ports here in the service, and down on the route, I'm actually specifying the target port to be the RPC server. Okay, so with this file, if we write it, and all we have to do now is an APB build. I'm including a tag flag here because I want to include the registry, Docker.io. If not, it would just use the image name in your spec file. And once this is built, you'll now have an image in your local Docker registry that you can actually deploy as an APB. But the only thing we're missing is that your origin cluster, which is running the Ansible service broker in the service catalog, needs to have some way to know that your application exists and the service catalog can populate it in the UI. So to do that, we've given you a nice easy tool, APB push. This is going to do some introspection on your kube config and check if you have an Ansible service broker running in your cluster, and it will actually push your image to the broker, assuming your broker is running in development mode. And the service catalog will pull the Ansible service broker to determine if there's any new APBs in its list. So now that we push it to the broker, we should expect to see it in the UI. And there it is. Okay. Nice little icon and display name. If we click it, you'll notice there's no parameters, just like we would expect. Let's go ahead and create a project, Ethereum, and let's deploy it. As it's provisioning, I want to show you what's going on behind the scenes. So let's clear this. Let's switch to the Ethereum project. You can see our APB container being created. Let's tell its logs. And here you see it create a deployment config, a service, and a route. Show you I'm not lying. Boom. That looks good. And we have a pod running. We can tell it everything looks fine here. You can see its HTTP endpoint opening on port 8545, which means that its RPC server can now be contacted by us using that route that we've generated. So let's get the name of that route again. And I'm going to run this little script I have, which I'll show it to you first. To just run 3 curl requests against that route. And it's going to check for the geth version, client version, whether or not that Ethereum node is syncing the blockchain, and whether or not we are on the main Ethereum network or a test network. I would expect to see us on the main network. Maybe syncing takes about 3 to 5 minutes to start, and version 1.6 of geth. So I'm going to run it with this route, and we have 1.6 client version, We're not syncing yet, and we are running on the main network. So just as we expect. Okay, very cool. Now we want to parameterize this application. To do that, let's delete this Ethereum project. I don't want to destroy my broker and service catalog. I just want to be able to update the spec, push it to the broker, and then deploy my new image. So to do this, we need to edit the spec file again and add some parameters. I have already typed up some parameters, make this a little bit simple. So I'm going to append it to the spec file. And here's what we got. We have 4 parameters. Replicas, which is going to determine how many pods to spawn. A Boolean for the test network to determine if we're running on a test network or the real main Ethereum network. A flag to enable mining. And some type of wallet address to be used to collect mining rewards if we do specify mining. For my demo, I'm not going to do mining, but it does work if you'd like to test it out yourself. So that looks good to me. Now that we have the parameters in our spec, we have to do 2 things. APB prepare. That's going to update our Docker file with a new spec. You can see it's a little bit longer than before because we have all the parameters appended to it. And one more thing I'm going to call out. You notice I have no required parameters because I just showed you could run Geth with no parameters before this, and it would still actually come up, just be syncing the blockchain and a client node. Now I'm going to specify no required parameters, but give the option to add some command line arguments. So to do that, we need to update this provision rule. And to do this, we essentially want to append some type of arguments to this command line. I'm going to copy a file I have written so we don't waste too much time here. And let's see what's different now. So the first thing, this replicas spec, I've now used in basic Jinja templating, that replicas parameter I'm passing in to the APB. So now no longer is it spawning just one, but I can specify the number of replicas from here. And then you can see on this command line argument, I'm essentially just appending flags depending on whether or not the parameters exist. So you can see this testnet flag if I actually specify the parameter for the test network. Now, the other thing that I added for this provision, to make this a little more fancier, I can show you guys some cool things you can do with an APB. I'm going to create a persistent volume claim. And the reason why I'm doing this is that I'm going to be deploying nodes which are going to be syncing blockchain data. If that container were to get destroyed and redeployed, we don't want to lose all the data that it's already downloaded or have to start from scratch every single time. So I've created a key store persistent volume claim with 5 gigabytes of resources. And you can see now at the bottom of my deployment config, I specify a new volume for key store volume using that persistent volume claim and actually mounting it into the Ethereum directory. This is going to allow all the data to be downloaded to actually get stored in a way that won't get destroyed every single time your container dies or is redeployed. And then the service and the route are going to look exactly the same. Okay, so that looks good. Oh, so one more thing we need to do is in here I want to go ahead and create a defaults file. Reason being that since my parameters are not required, some of my optional ones I just want to fill in with some empty parameters just in case something goes wrong when being passed the parameters from the broker. So this is kind of just a little safety check that I like to do. So to do this, I already have one of these, I believe. Oh, oops. CP. Into default main. So let's look at this file. essentially I'm just taking these 4 parameters, asking for environment variables in case someone wants to overwrite them, and if not, default them to either false, 5, or this string. So I'll write that. That's done. We are good to go. So remember, APB push is going to push our spec up to the broker, and then our APB build, so it's going to allow us to use this image. Okay, so now once I refresh the UI and click Ethereum, I should expect to see our new parameters, which I see here. And we can go ahead and configure it. So I'm going to select 4 pods and also enable the test network. This will just be a way for us to check to make sure that our flags are actually being passed into the command line. And yeah, I'm going to leave these 2 blank. I'll create the Ethereum project. Let's go ahead and create it, see what happens. While that runs, I want to look at what's going on behind the scenes. So if I switch to the Ethereum project, and I tail these logs, you can see it's the new image because it's creating a persistent volume claim. After that, it's going to create its deployment config and its service and its route. Okay, that looks good. So let's check for the deployment config. We've got a service and we've got a route. Awesome. And here are 4 pods being run, which is exactly what we expected, 4 replicas. And once they're all running, which looks like they are, we can test to make sure that what we've actually parameterized is working. So if you remember that script that I was running before, the RPC script, we expect now that the 3rd curl request should return a status of 2 or higher. That would imply that we're running on the test network. And remember, since this route points to all 4 pods, it's going to round robin select them semi-randomly. So click this route, and perfect. We've got a 1.66 version of Geth. One of our nodes is at that block in the blockchain, and we're running on some network that's not the main network. So our testnet flag ran. Awesome. If we go back to the UI, we can view the project, and you've got your deployment here, your service, and then your route. So that's it. That's pretty much all you need to do to package up a containerized application into an APB and get it discovered in the UI for testing. So I hope you found this helpful. Please feel free to document any issues you see with either CAT ASB or the APB tool. Thank you very much.